Bismillah ar-Rahman ar-Rahim. Suppose we observe three calls at a telephone switch where voice calls V and data calls D are equally likely. There are two types of calls, voice calls and data calls, right? So the voice call is represented by V and the data call is represented by D. Let X denote the number of voice calls, Y the number of data calls, and let R is equal to XY. Part A. What's the sample space, SAMPLE, sample space of the experiment and the corresponding values of the random variables X, Y, and R? What is the range of each of the random variables X, Y, and R? What's the PMF of each of the random variables X, Y, and R? So let's begin to solve this problem. So first of all, we observe three calls, right? And each call can be either voice or data, right? So it's basically a 3-bit number where each place is either V or D. So it can be, we can suppose that either 0 or 1. So if V is equal to 1 and D is equal to 0 and V is equal to 1, so then 3-bit number can have 8 possibilities, right? 0 0 0 0 1 0 1 0, right? And 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. So the sample space is given by, for example, D D D, all the three are data calls, then D D V, then this 0 is D, right? And 1 is V. So D D V, and then D V D, then D V V, then V D D, and then V D V, then V V D, and then V V V. So the total 8 outcomes are possible: 1 2 3 4 5 6 7 and 8. And it's given that each outcome is equally likely, right? Voice and data calls are equally likely, so the each outcome is equally likely. The probability of each outcome is 1 over 8. As there is a total of 8 outcomes, the probability of each outcome is 1 over 8. So and the corresponding values of the random variables X and Y. So random variable X is X denotes the number of voice calls. So number of voice calls, and Y is the number of data calls. And R is equal to X multiplied by Y. So so we can see that in this, for example, outcome, the number of voice calls is 0. So X is 0 for this outcome. And number of data calls is 3. So Y is 3 for this outcome. And so R is equal to XY. X is 0, Y is equal to 3, so R is also 0 here. Similarly, for example, if we take this outcome, so the number of voice calls, the value of X is 2 here. And the number of data calls, the value of Y is 1 here. And R is equal to XY, so X is 2, Y is 1, so 2 multiplied by 1 is 2. So R is also 2 here. So for each outcome, we can obtain the values of X, Y, and R, right? The random variable X and Y are random variables. So we can obtain the random values of the random variable X, Y, and R for each of these outcomes. So it's better that we we construct a table to write down the values for each outcome. So for example, let's write down each of the outcomes. Which is the let's write down the outcome, right? So for example, d d d, then d d v, then d v d, then d v v, then we have v d d, then we have v d v, then we have v v d, and then finally v v v. So let's be sure, 1 2 3 4 5 6 7 8. So all the 8 outcomes are there, right? And the probability of each outcome, let's denote this by probability of each outcome, right? So this is 1 over 8 for this, again 1 over 8 for each of the outcome. The probability is 1 over 8. Right? And the random variable, value of the random variable x, y, and r. So in this case, the value of the random variable x, which is the number of y's called, is a 0 here. This is 1 here, 1 y's call. This is 1 y's call here, right? This is 2 y's calls in this case, and 1 y's call. Then again 2 y's calls, 2 y's calls, and 3 y's calls here. So, and the value of the random variable y, which is the number of data calls. So 3 here and 2. This again is 2, and this is 1 data call only and 2 data calls, and this is 1 data call, this is 1 data call, and the number of data calls here is 0. So r is equal to x multiplied by y. So this is 0, 0 multiplied by 3, 2 multiplied by 1 is 2, this is 2, this is 2, 2 multiplied by 1 2, 2, 2, and 0, right? So this is the sample space of our experiment and the corresponding values of the random variables x, y, and r. So this solves our part A of the problem. So what's the range of each of the random variables x, y, and r? So the range of the random variable, range of random variable. So we see that x takes on values, only 3 possible values, 0, 1, 2, and 3, right? So the range, let's denote this by range of random variable x by sx, and this is 0, 1, 2, and 3. This is the range of the random variable x, right? So the possible values that x can take on. Similarly, the range of random variable y, so it also takes on the same values, 0, 1, 2, and 3, 0, 1, 2, and 3. And range of the random variable r, it takes on only 2 values, 0 and 2. So this gives us the range of the range of each of the random variables x, y, and r, right? And now with part C, what is the PMF, probability mass function, of each of the random variables x, y, and r? So probability mass function PMF. So this is also called probability distribution or probability distribution of each of these random variables. So if we look at the random variable x, for example, let's start with random variable x. Pmf of x. So it takes on 3 possible values, and we can calculate the probability for each of these values that it can take on. For example, for 0, there is only this probability, 1 over 8. It occurs only once, so the probability of occurring 0 is 1 over 8. Now probability of occurring 1, right? For the x takes on value 1 is 1, 2, and it occurs 3 times. So 1 over 8 plus 1 over 8 plus 1 over 8. So this is 3 over 8. Similarly, the probability that x takes on value 2 is 2 occurs 3 times. So 1 over 8 plus 1 over 8 here plus 1 over 8 here. This again is 3 over 8. And probability that x takes on value 3 is only, again it occurs only once, so probability is 1 over 8. So actually we can construct a sort of table for this PMF like this. We can write down the random variable x here, the possible values that it can take on the range of x 0, 1, 2, and 3. And then the probability that x takes on, the random variable x takes on a value x. The value x is denoted by small x, right? Any value x, it can take on any of these values, small values x, right? So as described here, the probability that x takes on value 0 is 1 over 8, because this 0 occurs only once, so this is 1 over 8, right? And the probability that it takes on 1 is again 3 over 8. And the probability that it takes on 2 is also 3 over 8. And probability that it takes on 3, x is equal to 3, is also 1 over 8. So this gives us the PMF, or the probability distribution of the random variable x. So this PMF can be written this way, and it can also be written in some other way, in many other ways also. For example, it can be, and PMF is denoted like this, and it is also denoted like this: capital X here, subscript, and then the probability of the random variable x takes on this small value x, and it is also denoted like this: x takes on this small value x. And this is, now we can write here like this in this table, and we can write here like this also. For example, the probability that x is 1 over 8, so the random variable here takes on values, for example, for x is equal to 0 and 3. The probability 1 over 8 is for values 0 and 3. And the probability that it is 3 over 8 is for random variable values x is equal to 1 and 2. And this is 0 otherwise, right? We write here this is 0 otherwise. So this is how we write down the probability mass function for random variable x. Similarly, the PMF of random variable y, we can write it, we can construct the PMF y in a similar way, right? We can construct a similar table here. For example, let's build this table. This is y, and this is the PMF of y. So the y, random variable y, can also take on values, 3 values: 0, 1, 2, and 3. 0, 1, 2, and 3, right? And if you look carefully, the random variable x and the random variable y, they are similar in many ways. For example, this progresses 0, 1, 1, 2, 1, 2, 2, 3, and if you read it reverse, for example, so then this is 0, 1, 1, 2, 1, 1, 2, 2, 3 in this direction. So the range is the same, and the probabilities are also the same. The 0 occurs only once here, so the probability of y getting a 0 is 1 over 8. Probability that y gets 1 is 1, 2, 3, 3 over 8. That it gets a 2 is again 3 over 8. That it gets a 3 is only 1 over 8, right? And this probability mass function can also be written like this. The PMF of random variable y can also be written in a similar manner. So PMF of y is denoted like this or like this, is again the same. So the probability 1 over 8 is for y is equal to 0 and 3, right? For values 0 and 3, and that the probability is 3 over 8 is for values y is equal to 1 and 2, and this is 0 otherwise, right? So note that this is x and y and r, all three of them are discrete random variables, right? Discrete random variables. Now the Pmf of R. So Pmf of R can be built in a similar way from this table here, right? So we can build this table. This is R, and this is probability that R is equal to takes on this small value R. So R takes on only two possible values, right? 0 and 2 only. So 0 and 2. So 0 occurs twice. So 1 over 8 plus 1 over 8. So the probability of occurring a 0 is 2 over 8. And the probability of occurring 2 is 6 over 8. Right? So I'm not going to actually make this ratio 1 over 4 or this as 3 over 4 to keep it in conformance with these other distributions. And also note that the total probability, if you sum all the values of the PMF, this is going to be 1. So 1 over 8 plus 3 over 8 plus 3 over 8 plus 1 over 8, this is going to be 1, right? 3 plus 3, 6, and 7 and 8, 8 over 8 is going to be 1. And similarly, if you sum all the probabilities here in this PMF also, this is going to be 1. And in this case also, if you sum all the probabilities, the answer is 1. So it can also be denoted like this, as said earlier, and we can denote it always like this. So this takes on value, for example, 2 over 8 when r is equal to 0, and 6 over 8 when r is equal to 2, and this is 0. The probability is 0 otherwise. So to recap, if we look at the PMF of random variable x and random variable y, the PMF is the same. We have this PMF of random variable y, and we have this PMF of random variable x. So both the PMFs are the same. Both the random variables are different, but they follow the same distribution. So that is why we have some unique distributions. We study some distributions which occur quite frequently. They are given a name, and for example, we see binomial distribution, we see exponential distribution, and some other kind of distributions which occur frequently, and many random variables follow the same distribution. So those distributions are described and discussed quite frequently. So this concludes the solution to this given problem.